All right, welcome everybody. Nice to see you to this new sessions of the law and technology and economics. I'm very pleased today to welcome Volker. I'll be very brief with his bio. He is the head of the research group at the Weizenbaum Institute. The research group has been renamed quite recently, and it's now called Digital Economy, Internet Ecosystem and Internet Policy. Volker is also a PhD supervisor, so it may be relevant to some of you here in the room. He is the host of the Clamatizo, and I actually never got that this was the acronym for Platform, Markets and Digital Society. I encourage you to have a look at that. It's available on YouTube, and it might be available elsewhere, or is it not? YouTube. Just YouTube, all right. And last but not least is one scholar that I can also consider to be a friend, so it makes the pleasure all the more relevant. So on that, please give a round of applause to our speakers, and the floor is yours.
Yeah, thank you very much. It's a great pleasure to be here, an honor, of course, as well. I can just say the same thing about Thibault. Thibault is a good friend. I'm an admirer of his research, of course, but also his various formats, like the Scalable theory podcast is, of course, a must listen, and all the other formats you have, and also this talk series. So I appreciate this a lot, especially any effort to bridge the gaps that bring together people from different disciplines, because that's, I think, what we need. So when we discussed a few months ago, right, it wasn't quite sure what the topic should be. I think I gave a topic suggestion, Thibault created that one. Then for me, this was a challenge. So then I filled this with life, and I hope I can give you the maximum today. Yes, so Thibault said it already, so I'm an economist by background, but for many, many years I collaborated with technologists, engineers, and computer scientists, now also with lawyers. There's a very, very good young lawyer from Amsterdam with whom I'm very fortunate to work with, Zach Cooper, currently working on law and economics and generative AI and copyright. And so I'm specifically happy to be here. I think I can skip my affiliations, all that stuff, and jump into it. So I thought I'd give you some context, because I think if we talk about solutions to problems, we should talk about the problem first. And I think if you don't get the problem statement right, like in math, what is the solution? You can do everything correctly, right? But if the problem statement is wrong, what's the meaningfulness of the result, right? So I think this is where I want to focus on, basically, and then mention or talk about some policy challenges here. Then, I don't know whether it's called a fireside chat. We don't have a fireside here, we could play the piano perhaps. Arno can play the piano. And then we have a Q&A, and feel free to interrupt me whenever you want. Just so you know, so I just listed a few, and here is Zach Cooper, this short essay, and this scholar I mentioned from here. We have the short essay recently published on SSRN, very provocative, I will read. So this is the few publications I recently had in the last 1.5 years, AI related, okay? Mostly Gen AI related. And this goes, lots of these publications are interdisciplinary. All right, so I will draw a lot of stuff. I don't have to be my co-author there. And of course, I speak in my own capacity, and of course, all errors are my own. That's, I think, what I should say in the beginning. Now, let's get some context. Now, of course, we observe an unprecedented essentiality of the infrastructures. When I talk about that, I mostly mean network computing and communication network resources. Okay, so cables, servers, routers, and all of that stuff. And actually, this is super important for socioeconomic participation of individuals and businesses. When I talk about end users, I mostly talk about individuals or business users. Okay, so if I don't do otherwise, end users would comprise both of them. Arguably, this has been, pushed by the COVID-19 pandemic. I don't have slides on that. I published a book on that where we really looked into the shift, right, towards online services and how it basically changed the ecosystem in terms of investment and all these things. Lots of investment there. Now, we're moving towards a hyper-connected society. What do I mean by that? We're going to a society where basically everyone, again, individuals and companies, and everything, smart objects, things are always on. Networkable, interconnected, and computing, or increasingly AI assisted. Okay? So we talk about AI-driven ecosystem, I think we should mention this. Now, we have wearables. I don't have a very old-fashioned watch. We have smartphones everywhere. We have a wearable. We have also embodied computing, if you've heard of that. So there's ingestibles and all of that stuff in the medical field. So this is very, very important to see this as part of an ecosystem, so the wealth of devices we have and the various demands these pose to all kinds of stuff, networking, compute, but also like energy efficiency and all this stuff. Okay, there's some buzzwords. I don't list blockchain or Bitcoin here, but apart from that I have almost everything. Platformization, datafication, cloudification, softwareization, essential propositions of the digital economy. So I don't know whether you folks know that stuff. Probably you don't know softwareization so well. Softwareization basically means you have a lot of devices in networks, and usually they were combined. There was a hardware and then there was a fixed software on top. But now you can program that stuff. You can use off-the-shelf hardware and program that stuff how you want. So this makes networks and networking much more agile and more customizable. It's very important for traffic engineering, for efficient usage of resources and so on. And also to more adaptively and flexibly meet changing demands. Okay, so we have digital transformation processes that are fueling all of these technological changes, and also, of course, increasingly by machine learning and AI. And so just a few things. First of all, we have an unprecedented possibility to collect and analyze data. We have advanced cloud computing, all that stuff. We have also edge computing. Our devices can do a lot of stuff. We can analyze structured and unstructured data. A lot of new capabilities arose with Gen AI. We have with Gen AI also, AI in general, much more enhanced automation potential. So the continuum of human plus AI is becoming much richer. We have changed economics and content creation, most of us know, right? Enhanced customizability at scale and in real time, which I was just tempted to call this mass customization 2.0. Okay? So you can interact with something and get a personalized result or just by response at scale. Arguably, Gen AI helps to leverage more decentralized innovation activity by reducing innovation barriers and costs, and also by shortening innovation cycles. We can also do, if you've heard of digital twins or something like this, we can have a lot of simulation. We can have a city, we can basically have a virtual copy or replica of the city, and then we can simulate all kinds of stuff, like catastrophe scenarios, urban planning, and then we can run simulations quite quicker as we would in real life. If we do it with machines, we also have much less waste. Okay? We can parallelize that stuff, we can scale up innovation cycles tremendously. And all of this is, in a sense, changing. Whether I should call this disruptive, I don't know, but that's certainly here. So what we have now, when we go back to ecosystems with digital economics, and I call this here on advanced cloud and AI steroids. It's a bit more, a bit of everything. It's amplified, but not everywhere, okay? The context is very important. But we see a scale in scope economies on the supply side, which gives you cost advantages, but also the demand side, with all which we economists call network effects. These could be direct and indirect, could be regular, basically, attached to users and the usage, or data-based, based on data-driven learning. Yeah. So I can either have more value by having more users on the network, but also by interacting with the system gets more data and can improve based on the data it gets. So there's a lot of feedback loops and complementarities and so on. So this is, again, context-specific, different. Sometimes it's not super disruptive, sometimes it is. So we need nuance. That's one, of course, I will mention this a few times. Now, we have a lot of challenges based on this and a lot of responses. This is just a few. If you guys, of course, I've got lawyers in the room, so you know about all of these acts and laws and regulations. And this is just an overview of the most recent stuff that affects the digital economy future, as I call it here. But it's not everything. We have more. So we have a cybersecurity act. We have a Cyber Resilience Act. Last week in London, I got to talk about the Cyber Resilience Act, just adopted in October. We have a Green Deal. We call it a twin transition, right? So digital inclusion, we have the Digital Decade Policy Program, where we have investment goals by 2030. We have AI factories, or at least we're building them, like supercomputers for startups, to get access to GPUs and all that stuff, and to do AI-relevant innovation. We also have, and you probably have seen this, the letter and also the Driving Report. The letter report wasn't maybe that famous, but not that famous, but the Driving Report get a lot of visibility. So in the end, what we see, first of all, is a complex and evolving set of policy goals, which are in this sense use-specific, right? A lot of this stuff has been referred to in the context of the Brussels effect. We were first movers, and we tried to basically set a standard, a template for the world to follow. But here, reconciling social welfare, industrial, and competition policies and policy goals confronts policymakers with a complex mix of challenges, right? It's not easy. And all of this basically is done at the same time. And again, all of this is relevant, in a sense. And yeah, so this is something just to show you guys. I talk about challenges, but of course we have a lot of stuff, and we will not criticize or critically discuss these acts in detail. Okay, give you more context. Devices and stuff, I mentioned. We have more applications and services now. As we speak, new apps are developed, services are developed. These have complete maps with respect to network performance, compute, data locality, mobility, privacy, security, energy efficiency, all of that stuff, okay? So it's not like an easy thing to accommodate these demands. Responsive to this, we have seen, and this is more computer science perspective, right? That there's a seismic shift in the way the internet is implemented, where servers are positioned, where data is stored and processed, and how and from where content and application services are distributed and delivered. I will give you some screenshots in a second to illustrate what I mean. So it could be on-premise, for example. There could be some compute at a company, could be at the edge of a network, could be in the cloud, there could be hybrid strategies and so on. Complicated. So when you think about service provision, then there is basically not a single resource involved, right? But rather a complex involving amalgam of resources that are interconnected and complementary, hardware and software. With software, I include machine learning, AI, and all these algorithms. Computing and communication network resources, devices, data plays an important role also. And these resources are owned and managed by different entities that are often competing, have opposing interests. Okay, that's really important to understand. Also, some of these are proprietary. They're dedicated and managed, not open to anybody else. Some are open, but openness is not one thing. Thibault has a paper, I guess, we sent a pamphlet about openness of elements. This is a very complex thing. There's different degrees, varying degrees of openness. That also means to what extent are these resources shared or not? Is there a bottleneck? Is there discriminatory behavior? No, is there foreclosure? Very complex. Finally, this is all of these ingredients make AI-driven ecosystems and cause a complex and changing fabric of technical and business relationships. That's very important. There's technical and business relationships. And a lot of interdependencies. And we don't even always know about these dependencies. A clear idea would be a supply chain that would be easy, but sometimes these value chains, delivery chains, or dependencies change because there's a dynamic adaptation of how a service is delivered. Okay, so traditionally we've been talking about horizontal and vertical business relationships. Horizontal would be an interconnection between network and not network, for example. A complementary vertical relationship would be a platform and let's say the iOS and an app based on iOS, right? That would be vertical. But give me more. I will show you some examples here. Okay, so we have more complex and fluid PC structures and also value chain configurations. I don't know, it's a bit complicated, but that's how it is. We have to embrace that. So there's changing ownership and control structures, competitive and innovation dynamics, and potentially also power balance, okay? We have in our heads, we think about regulation, there's power balances between folks that we need to regulate. But not necessarily everything is set in stone. Something can be changed, something could be amplified and get worse, and so on. All right, so what I want to show you here is one of the drivers when we talk about AI-driven ecosystems. I think everyone knows about the big tech companies, the large tech companies that have the three big guys that have the largest cloud services and infrastructures on this planet. This is basically Amazon, AWS, this is Google, and this is like Google Cloud, and this is Microsoft Azure. Now, let me tell you one thing. None of these companies started out as a cloud company, right? None of them. Just so you know and have the back of your head, because what we sometimes try to do is build our own cloud companies, okay? None of these guys started as a cloud company. This was a business model innovation over time. Now what these guys did over time was they had developed multi-layered cloud-based platform ecosystems. So they started a search engine as a provider of operating system and so on, but they've invested in infrastructure, hardware, if you will, also for software, that are some, I call these technology substrates. And these are basically forming global private network infrastructures that have physical and virtual links and strategically distributed servers, like data centers. Can be large data centers, large units of data centers, or more distributed, smaller units. And these are highly manageable, extensible, and scalable substrates. What does it mean? It's like it can cater a lot of innovation on top, okay? A lot of stuff is building on top. And because a lot of stuff is building on top, this stuff was developed, okay? And this is a process over many, many years. They didn't start 3 years ago. The attention now is huge, right? I'm surprised that nobody was looking into this like 5 10 years ago. I'm a humble guy, of course. I did write some papers about that stuff many years ago, but of course it wasn't, the attention wasn't just there. But it was visible. Computer scientists saw this, so of course I wasn't the guy who found that stuff. Anyway, these substrates and these ecosystems are not the same. I think Nicolas coined the term oligopoly theory to show that there's a different, there's a differentiation between these ecosystems and also in these substrates because they're different business models. And again, they come from a different basis, search engine, operating system, and so on. But they also know cloud providers, okay? Now walk you through quite quickly how these networks look like, or what these networks look like. And I call this a stylized anatomy of such a global private network, okay? Because I want you to know that there's different elements to it. It's not only data centers. Okay, so this shows basically here this what I call a global private network that combines a distributed serving infrastructure, servers, and a private network, a backbone network. Backbone means wide area network, connecting data centers and so on. So the figure shows how physical and virtual private links, the blue lines, form a private wide area network, a backbone that basically connects strategically important network locations. The orange dots are data centers, and the yellow dots are points of presence where the network provider interconnects with other networks, for example, with internet service providers, from which basically end users we get our internet access service from, right? There they exchange traffic. So as we can see, the footprint of the network is depicted by the inner circle. This is a sort of proprietary sphere, if you will. But what does it mean? It has maximum control there. So, and this footprint, and I'm not talking about carbon footprint, right? But the footprint of this infrastructure can be expanded to reach closer to end users. And again, the end users are here, the houses, and the houses outside the circle, individuals and business customers. Now, there is a gap, right, between this circle and these guys. And this is what we call the public internet. Okay? So this must be traversed one way or the other. Two things are essential here. First, this one. There exists managed connectivity service, mostly called direct cloud connects. So an enterprise can connect directly via private link with this inner circle, okay? So the shared infrastructure of the public internet can thus be bypassed. I told Thibault just in a blog post from 2 weeks ago, the CEO of DKIX, which is one of the largest internet exchange points. You have a huge one here too, it's called AMSIX. Wrote a blog post and said too many enterprises still rely, I quote, too many enterprises still rely on public internet or third-party transit for connecting data and AI systems. This creates considerable performance and security issues, with enterprises having little or no control over data pathways, network bandwidth, and latency, and the security of critical company data in transit. Okay? That means there's stuff that is a bypass to the public internet that makes sense and is possible. Second, providers can expand their footprint beyond the inner circle by deploying servers, these red dots, outside the inner circle. Basically, this is basically called off-net servers, and these servers are deployed within terminating networks, for example, within the networks of our ISPs. So if I'm a customer from British Telecom or Comcast or something, and I want, for example, a Netflix movie, I get it from the network I subscribe to and I'm connected to. I don't get it from the internet, right? I get it delivered from much more local place. And you see that lots of these red dots, and this is important, because they're very widespread, and we have this, always when performance is important, these capacities are shifted very close to where the demand is, geographically speaking. It's just a few kilometers off. That means signal transmission speed of light, maximum 300 kilometers per millisecond, right? Very low latency, very good performance, very good real-time capabilities. We don't need it for everything, but for something we needed. So just to show you here how this could look like, or what this could look like, this is just an illustration for myself and lots of red dots. Usually these red dots are where you have lots of populated areas, so Netflix looks similar like this, Google's network looks similar like this, because Google has a red dot network, if you will, for delivering their YouTube content, okay? And then the data centers, of course, and then they have points of presence. So this shows you how this thing looks in, let's say, more real-life terms. And just to show you some data on this is a paper from a paper I wrote 2021. And we had secondary data from other people, but we looked into, did they have, like what did they have? What infrastructure did they have? Data centers, all of the big guys at data centers. I listed these 4, in the paper we have more, but these are the guys who do GenAI stuff at the moment, right? So the yellow dots, the points of presence, hundreds. So they interconnect at hundreds of points, ideally very close to their customers. They have a private backbone, and they have a presence in many, many, many networks, okay? So Google was here the champion with more than 3,800 networks. That means within the network, customers from these networks can get the stuff they deliver from inside these networks. This is a bit like what new content delivery networks basically say. That means you try to have a cost-efficient, high-performance delivery, and that's why you basically copy the most likely viewed content very close to what the customer wants. Just to show you, there's a very strong physical dimension to the internet, and the internet is often very local, okay? Some of the stuff we get from very close. Now, I went online this morning, and I don't know exactly how accurate this map is, okay? But just to show you some stuff, there's subsea cables, and then you see different providers here, and then you see these dots, and this is locations, points of presence, data centers, and so on. And you see, of course, the Netherlands, and I also looked into Amsterdam for you folks. This green stuff here is Netflix. I don't know exactly, you might know where we are. I don't know where we are. And this is here, we have Akamai, which is the largest CDN provider. They deliver websites and also content like, video and that stuff. We have Cashfly, we have Amazon, and so on. This is in Amsterdam.
Is the Amsterdam Science Park also? Because there are big server towers there.
I know exactly where that stuff is. And I know exactly how accurate this website is. I just want to show you, sometimes you communicate, you go online, but you get the stuff from very local. Okay? An American website is not delivered from the US. That you guys know. I know most of you know, but this is a very efficient way of delivering and running the internet. Otherwise, yeah. Okay. So I will keep that short and skip some slides for now, because I have many, but I take the liberty to have a few minutes extra, but only a few. So why is this important? If you think about what I just showed you as a basic, like as a substrate, the more capable and flexible that stuff is, the more that can build on top. That means a lot of stuff is also built on top. Now, these substrates are used to deliver services from the same provider. For example, Google, Amazon, they deliver their own services, but they also deliver stuff from third parties, okay? Simultaneously, basically, with the same infrastructure. And also, don't forget, we'll talk about very quickly about partnerships in GenAI, right? This is not, for example, Microsoft and OpenAI, they are not the same entity of a partnership. So technically, OpenAI is more of a third party, right? It's not like a Microsoft service, but they have Microsoft services where they use OpenAI stuff. So this is why it's a bit complicated, and that's why I have to show you that. But important to know is there are, in 3 different layers, investment and innovation flows, okay? And this technology substrate enables, in our case here, AI, but also defines its boundaries. It basically determines what can be done. But this is not a static relationship. This is like an innovation investment ping pong, okay? This gets more capable, more stuff is possible here, and this feeds back, and so this is like a ping pong. And this is then an innovation and investment feedback loops. This is a paper that is currently, I will skip that, with Johannes Bauer and a computer scientist from TU Berlin, Arash Purandan, where we look into also how public policy shapes that. Because this is not kind of evolve completely free, rather than free, but there's also public policy, antitrust, competition policy and regulation that might have an effect on these dynamics and how these layers evolve. Okay, now when we have different substrates, different networks, they facilitate different things. If we think about in a two-dimensional way of the innovation space, and this is where we are now, and this is an information economic perspective, we can say, well, it's like a capability. Let's say, think about non-explored innovation space like a dark room, and everyone has like a flashlight, okay? A different flashlight, and we point to a different direction because our business strategy is different, how we design our substrate is different. So in the end, this means the possibility space for new innovation that varies, but our design decisions, what we want to do, how we structure and how we build our substrates determines what can happen on top. And in this paper, and this is a bit too much for you guys here, is we want to figure out, this is just a high-level stylized illustration, right? This is not empirically substantiated, this is just to show you there could be different things. And there's private interests, what we want to, where we want to go to, commercial interests, how to evolve, and then there's also public interest. And of course, this is something which is a fundamental policy question we should look into. And this is, I wanted to show you here, that this, if there is a mismatch, then there might be some, need for intervention. And then in this paper we explore how we can do this. All right. Now, recently, these substrates have experienced a lot of investment, and you probably have all seen this. So I mentioned the big guys, Amazon, Google, Microsoft, Nvidia as well. You probably have seen how the stock of Nvidia skyrocketed, and we see here 2023 investments by different companies into different, into various here for example, foundation model companies. And interesting thing is here, look, Amazon invests in Anthropic, Google Anthropic, right? Salesforce Anthropic. Interesting. Google Runway, Nvidia Runway. I said that, horizontal, vertical. I mean, this is still basically happening, but this is interesting, right? They invest in the same companies. And this is, I think, I don't know, I'm not going to look into so much, merger stuff. This is not necessarily merger-related stuff, but it's about partnerships. And there's lots of joint interest and investment. And here was this news I want to show you that for 2024 alone, the Big Four plan to invest $200 billion, mostly in data centers, chips, and other gear for building, training, and deploying generative AI models. Now, of course, we can talk about this as a hype or it's not a hype. If they invest, this changes something, okay? Now, making this even more complicated, every one of the big guys plays on this field, on this pitch, right? They have their own foundation models. They also have partnerships. Again, we see Anthropic, Mistral. Okay? This is from the CMA. They had like a nice report where they basically show how different companies, these large tech companies, interact with these smaller developing or foundation model firms. But that's not everything. Some of these guys have hybrid strategies. So OpenAI has their ChatGPT or their GPT integrated in Bing, their search engine, but has also launched their own search GPT recently. Again, OpenAI's GPT is integrated as Copilot in Bing, but also in MS Office, GitHub Copilot, Skype, Microsoft Azure, OpenAI Service, Developer Platform, and so on. So not everything Gen AI is we interact with directly, okay? That's very important to know. Again, Nvidia, for example, has launched their own LLM recently, so you see a lot of vertical integration in any direction, and also Microsoft, for example, just, I think they already, I don't know whether it's already used, but they plan at least to have their own AI chips. Again, very, very, very much entrepreneurial activity. It's crazy. So lots of challenges emerge, and when we think about this, is value generation capture, what's the key technologies anyway? And it's not so easy anymore to see them. Who controls the production, collection, curation, access to data information? How can we enable social and economic participation? What is gatekeeper control? Economic power, market power, can we define markets? What measures are needed to ensure consumer protection, transparency, and so on? So this is complicated. And I want to briefly walk you through a few challenges and policy challenges, and I came up with a lot. But I think I gave you a nice selection of challenges, which is tough enough. Okay, we want to have AI for good, not for bad, right? So there's a wide range of benefits in the use of AI for good health, education, and so on. We can use it to automate stuff, to have assistance in tasks. That's wonderful. But there's also a lot of course, tools that raise concerns. Manipulating consumer choice, for example, to affect first-degree price discrimination, to extract consumer surplus, promote fake news, to disrupt voting, for example, or generally to lower the signal-to-noise ratio, which is a big issue. For example, it might be used to flood content moderation systems, because there's humans usually, right, in content moderation. And if you can scale up that stuff and confront these moderation systems with synthetically generated content, that's actually a problem. If you guys know about cybersecurity, this is a bit like a denial of service attack. That would be conceivable. Create synthetic content, you probably heard of revenge porn, phishing, other cybercrime. That's the issue. Then there's something that I call the AI literacy conundrum, and you guys are lawyers, and I don't know what informed consent per se means, because now I don't know what it means. Because it would be interesting what you think. So, in my view, the gap between AI proficiency, the ability to use GenAI tools, and literacy, really using it properly, understanding its implications, is growing. The technology gets much more complex. It's very opaque for us, but it's easier to use than ever. Okay? So I think this gap widens, raising concerns about informed decision making by end users. Fundamentally. I don't know how to fix it. Then I think it could be, but I don't know, GDPR probably prevents this. There might be intertemporal mismatch. So I give my informed consent, even if I could give my informed consent, I might make an informed decision based on today's state of technology. But future, for example, AI advancements such as GenAI, may extract insights from data in ways a user cannot anticipate at the time of consent. Okay? So I give my consent. For example, I have a YouTube channel, right? Plumber channels. I upload these videos. These were used to train LLMs. I didn't know. And I think when I uploaded this, I didn't know. I didn't know about LLMs in 2021. So I don't know, but this, I know the GDPR protects us from this, but not everywhere in the world the GDPR. Then, of course, generally speaking, GenAI is not a singular thing, right? It describes an evolving range of technologies and tools that are becoming more pervasively deployed and used across all imaginable contexts, industries, and layers or components of value chains. They're not necessarily consumer-facing, so it's very hard to know whether in something I consume, some GenAI stuff was involved at some point. Very hard. Also, content is sometimes indistinguishable. I don't know if you've read probably Zach's paper. Yeah. So it's sometimes indistinguishable between content that is purely human-created or humans plus AI. And then, of course, a different question is whether this is relevant or not, how we deal with it. That's a bigger conundrum. So, leads me to my next point in a sense, is data provenance, copyright, and data feedback loops. Very quick. So model training can be based on different types of data. They could be public, hugely contested at the moment, fair use exemptions, all that stuff for you lawyers. Could be acquired by licenses or so. Could be proprietary, it's my own company data, or it could be based on user data. So users might be incentivized to use AI tools and generate data, thus creating data feedback loops. And yeah, there's debates about the role and criticality of data for GenAI, the use of synthetic data for good, what it can, what the limits are to use synthetic data to basically make up for a lack of other data, let's say. Data scarcity, data walls, licensing, and so on. But again, data and compute needs are highly context-specific, not the same for all data tools. Not all use cases rely on continuous stream of real-time data, for example, that with biases, give language issues, or inherent limitations to data and to get access to get data into the model training actually. Okay, then I mentioned this. There's these two papers by Zach, one by himself, the long one. I don't know if you've already enjoyed the short one, the provocative short one.
No.
Yeah, there's key legal and economic issues that have emerged around input data used to train AI models and the creative outputs generated by these models. Copyright disputes are all over the place, of training data, and we see already a decline in the AI data commons. The data that is publicly can be basically scraped or crawled, can be used for AI. This is where Shane Monkey and others work a lot on. Then this point here, many Gen AI tools, right, are very interactive. So we interact with them, we give data. So they may create data feedback loops that enable data measurement effects, customization, personalization, which can influence end user behavior and raise switching costs. Think about a company that has a social media network and uses these data for training, but does not give this data to competitors or anybody else, to third parties. So if they install smart data feedback loops, then they might have a competitive advantage. This is a bit more speculative, but happening in life, leading scholars, economics on network effects and data network effects, describe such feedback loops. It's highly recommended. A very recent working paper on competition policy and the AI, very good. Okay. Now, allow me to very briefly talk about the paper that Bill Lear and I contributed to, a very nice volume Thibault edited with Alan Albert, right? About competition policy of the generative AI waterfall. So Bill and I were thinking about, we don't really know what the future will bring, what the challenges are. But we know that there will be some change, and despite unknowns and unknowables and all of that stuff, doing nothing is not the best solution. So what can we do to prepare for the stuff that we don't know yet, to adapt as quick as possible and basically be on top of things? That's a very high level idea. So we came up, and we'll walk through quickly. I of course encourage you to read the chapter, maybe Thibault you can share it. We say that to craft good Gen AI competition policy, it will be important to focus on digital infrastructure policy, okay? So digital infrastructure, I talked about a lot today. With special attention to building a sound measurement ecosystem. We have some issues, we don't have the insights we sometimes need to craft the problem, to understand the problem properly and to enforce it effectively, right? So we have all kinds of people conflict with measurement problems. So Bill and I, we have like 3-4 papers now, I guess, on measurement ecosystem in different contexts. First, we have three high-level insights I will walk you through quickly. Digital infrastructure is critical. So, as I mentioned before, the amalgam of entities that comprise the ICT sector is the nursery and the foundation that makes Gen AI possible, and also where the direction of innovation and its intersection with real-world effects may be best first observed. That's the first thing. Then, evidence-based decision-making. So, AI-driven ICT ecosystems rely on a set of complex competitive value chains with distributed, technical and economic control. So what we need, this is the complexity of measurements. Cross-layer, end-to-end composability of measurements are needed, right? And means to facilitate a trusted exchange of information. What it also means is you have different measurement points with different components that you measure, and then you need to fit this all together and make sense of it. That's hard. You need something like an algebra to make sense of this. And we don't have it yet. But we will need it to make really sense of what really happens and what the economic consequences of it is. Yes, and very critical here, policymakers need institutional multidisciplinary capacity. It's needed to jointly address the technical and economic issues that will continuously arise and challenge pre-digital legacy approaches to competition policy. Context is key, not necessarily so, but there will be contexts where this will be. So we need more holistic and active integration of expert engagement among technologists, lawyers, social scientists, including economists, and others who are broadly familiar with digital technologies. Right? This is a lot to ask for. So from a competition perspective, competition issues, we basically explain how we need to make sure that shared access for all bottlenecks is necessary. A bottleneck is a resource that is necessary and cannot be bypassed. This, I think, is known to most people. And we basically say what roles AI tools play in creating such bottlenecks, but also how they can help us in remedying this. Same, we need ecosystem switching. And for that, it's of course important that we have proper information and know artificial barriers that impose switching costs. Here again, we explain how AI technology can be a problem and part of the problem, part of the solution. Give you an example. You want to migrate from one platform to another platform, you need to adjust your code. You might use AI to adjust the code more quickly and in a much more cost-efficient way, so that the switching costs decrease. Yes, and finally, there's stuff where competition policy doesn't help us because competitional infrastructures don't exist, or it's not available, which is also important, and require quality, capability, usability. And then we need to think about industrial policy measures. And yes, go read the chapter to find out a bit more. I will close with these very brief 3 points. First, we need more multidisciplinary engagement feedback. It's an amazing talk series. It's great to be here. I hope you guys see that. I know it's complicated, but I think there's no way around it. We can't avoid it. We need to work together. So we need to craft good policy, we need to have an exchange, we need to collaborate. And so this is something that is a mission statement here. We need to also, as companies need real-time situational awareness to manage real-time systems and so on. But also we know that if this information is valuable, the process is inherently strategic. Right? So we need to have an appropriate measurement ecosystem that takes care of this holistically. And finally, we need capacity to detect and act. That's the last one. So complex AI-fueled or driven systems cannot be controlled on the basis of exact design constraints, since as we call the information comes to state space is too large. We rather have guardrails. You can think about this as regulatory nudging, where we basically are monitoring the process and then basically correct as needed. So we need to be able to detect when bad or good things are happening and be capable to act to retard, encourage, reduce or amplify harmful benefits. This only works with adaptive frameworks because digital technologies and platforms, value chains, and so on, I mentioned this before, continue to evolve, and we must consider co-evolution of different components, active systems, because there might be multi-dimensional watershed effects. If this is such an interconnected thing, you might intervene at some point, and then something else might pop up. So you need to have holistic analysis, which also basically would circle back to the third or fourth slide, where I had this huge list of regulations we have at the moment. So problem statement is key, context is key. Easy solutions are probably not the answer. Thank you very much.